So the main goal for this section is solving rational equations, but just like with everything we've done involving rational expressions, we're going to start by looking at fractions. So first we're going to practice solving equations that contain fractions because the process is very similar to solving rational equations, okay? So practice with fractions, steps for clearing fractions from an equation. So this is just a regular old linear equation. This is not rational stuff at this point, but the process is the same. So let's practice with something easy, kind of wrap our head around what those steps would be, and then we'll apply it to the more complicated algebra in the next videos. So when you're dealing with a linear equation that contains fractions, the way you would clear those fractions is to start by finding the LCD. So look at all of your denominators and determine what the LCD would be. You then multiply both sides of the equation by the LCD and then just distribute it. But for me, I show it just kind of a little bit more individually. So what I say is multiply all of the terms by the LCD and then simplify and solve the resulting equation. So again, we're not into that rational part yet, okay? All of our denominators are just going to be plain old numbers. So we're going to look at solving each of these linear equations. So we have two parts to example one, and the directions again just say solve. So when you have equations, linear equations that contain fractions, you have to remember, we've already talked about this, but you have to remember you want to clear the fractions. It just makes life a lot easier and it makes it something manageable that you can work with. Okay, so you want to find the LCD. So we're going to look for the LCD. Let me get my little glove on. So we're dealing with two denominators. We're dealing with 8 and 6. So we want to find the smallest number that 8 and 6 divide into. So we've got 6 and 8. I like to start with the larger denominator, 8. Does 6 divide into 8? No, so that can't be the LCD. We then start looking at multiples of that number. So 8 times 1 is 8. That didn't work. 8 times 2 is 16. Does 6 divide into 16 evenly? No, it does not. So we look at the next multiple of 8, which would be 24. Does 6 divide into 24? Yeah. Does 8 divide into 24? Of course. So we would say the LCD is 24. Now we want to multiply all of the terms. Even if the term didn't contain a fraction, we still have to multiply all of the terms by the LCD. And remember, terms are separated by addition, subtraction, or equal signs. Okay? So I'm going to show this step. You don't necessarily have to show this step depending on your comfort level with this, but I would say if you're struggling even a little bit, show this next step. So I'm going to take 24 times x over 8 minus 24 times 1. That's going to equal 24 times 7x over 6 plus 24 times 2. So I found my LCD. Let me scroll just a smidge. My dog is going to town on a Chewy behind me, so you might be hearing her. So we found the LCD. We're now at the point where we've multiplied all terms by the LCD. All that's left is to simplify and solve whatever equation results from this. So let's do the simplifying part. So I'll do the simplifying in red. So looking at my first term, I have x over 8 times 24. Well, that 8 in the denominator divides into the LCD of 24 3 times, leaving me with just 3 times x. Already it's easier to work with. And then negative 24 times 1 is just negative 24. And then I have 24 times 7x over 6. Well, that 6 in the denominator divides into the LCD of 24 4 times, leaving me with 4 times the numerator. So 4 times 7x is 28x. And then 24 times 2 is just 48. So I get plus 48. Now we just have a regular old linear equation to solve. Now it's been a minute since we've solved linear equations, but we know how to do this already. So let's go ahead and get all of our x's to the left and all of our constants to the right. Now you can hear her drinking water. That's my dog Winnie. So we want to subtract 28x from both sides of the equation. Well, 3x minus 28x is just negative 25x. Drop down your negative 24 and your equals. On the right, 28x minus 28x is just 0, and 0 plus 48 is 48. Okay? So now we want to get the negative 25x alone. The issue is the minus 24. So I'm going to move the 24 by adding it to both sides. Well, negative 24 plus 24 is 0, so that leaves me with negative 25x. And that equals, let's see, 40, 60, 72. So now we want to get the x by itself, and in order to get the x by itself, we divide both sides by its coefficient, which is negative 25. So on the left, negative 25 divided by itself is 1. That leaves me with just 1 times x. And 72 divided by negative 25, you could try to simplify, and if you did have a fraction that would simplify, you would do so. But in this case, 72 and 25 have no common factors. So we would just say the final answer is negative 72 25ths. You could also write that kind of pretty. You remember doing set notation where we wrote it like this? That's kind of the fancy way to write it. So that would also be appropriate. So that's all there is to it. When you have an equation that contains fractions, find the LCD, multiply by the LCD, and then you have something like this that no longer has fractions. That same step is going to follow us into the next big concept, okay? But for now, let's look at part B. So part B is very similar to part A. We have a linear equation with fractions, so we want to get rid of those fractions. We're dealing with denominators of 3, 6, and 2. So I always like to start with the biggest of the denominators, which is 6. We know 6 goes into itself, so that's fine. But do the other denominators go into 6? Well, 3 certainly divides into 6. 2 certainly divides into 6. So that tells me the LCD is just 6. We don't have to do any more work. Okay? So now we're at the point where we want to multiply all of the terms by the LCD. And remember, terms are separated by addition, subtraction, or an equal sign. So we've got 4 terms here. All 4 terms need to get multiplied by the LCD. I was about to say the LCD was 4, 6. So I get 6 times 4x minus 9 over 3 plus 6 times x over 6 equals 6 times x over 2 minus 6 times 2. And then we start to simplify. We want to divide all of our denominators into the LCD and then just solve what's left. Okay? So for the first term, 3 divides into 6 twice. And what that's going to do is it's going to leave me 2 times that entire numerator. So we do want to use parentheses around that first numerator. So it should look like 2 times 4x minus 9. I'll distribute in the next step. For the second term, the 6 in the denominator divides into the LCD of 6 one time, leaving me with just 1 times x, which is just x. And then in the third term, the 2 divides into the LCD of 6 3 times, leaving me with 3 times the numerator of x, or 3x. And then finally, negative 6 times 2 is just negative 12. And you're left with something that is a heck of a lot easier to solve. This is just a regular old linear equation. Okay, first step is to distribute on the left. So 2 times 4x is 8x. 2 times negative 9 is negative 18. And then I just write down the rest of the equation. I can now combine like terms on the left. So 8x plus x is 9x. Drop down your minus 18 and the rest of the equation. We want to get all of our x's to the left, all of our constants to the right. So let's start with the x's. I want to move 3 x's to the left. I do that by subtracting. So 9x minus 3x is 6x. Drop down your minus 18 and your equals. And then on the right, 3x minus 3x is 0, and 0 minus 12 is negative 12. So I want to get my 6x's alone. The issue now is the minus 18. So in order to get 6x by itself, I add 18 to both sides. Well, negative 18 plus 18 is just 0. 0 plus 6x is 6x. I'm going to move that kind of over here. And then on the right, negative 12 plus 18 should be just 6. So hopefully you've got room. I wrote a little too big, but we've got 6x equals 6. And then in order to get the x alone, I just divide by its coefficient. So I want to divide both sides by 6. 6 divided by itself is 1. 1 times x is x. And 6 divided by itself is just 1. So we would say the final answer here is 1. So the reason I'm showing all of the, like with every topic we've covered, I start by showing you with fractions, just because it's a little bit easier and the steps are generally almost identical. So if you can understand these steps on how to get rid of fractions from a linear equation, that'll help you understand the steps that we're going to look at in just a moment where we solve rational equations. That's where you can have algebra in the denominator, okay? So same idea, just a bit more involved.